Well, hello everybody and welcome to today's webinar. The title of today's webinar is Integrated Potential Fields Modelling Software. Now, as Vinny said, my name is Anne-Marie and I work for a company called ArcX. ArcX have developed XField as a plugin to OpendTect, and I will be talking to you about this through today's webinar. So let me go through the agenda for today's webinar. We'll start with who ArcX are and what we do. I'll be talking about potential fields data and why it's useful in our industry. I'll be talking about what XField is. Then we'll move on to a short XField demonstration, and finally I'll summarise our webinar from today. So firstly, ArcX, who are we? Well, ArcX is a geophysical service company and we specialise in potential fields data, namely gravity and magnetic data. As a company, we offer both multi-client and proprietary services. We offer acquisition services for full tensor gravity gradiometry data, and we have 3 airborne platforms to do this. We offer interpretation services and have an in-house interpretations team that specialise in gravity and magnetic data. We offer data processing services for conventional gravity and magnetic data and gradiometry data. We offer data management services. A lot of companies have a vast amount of data that they need to save and store in a way that's useful to them, and FieldBank is a service we offer that helps tackle some of the challenges around this. We offer data brokerage services and currently have contracts with several global clients. And finally, we offer interpretation software, both for 2D and 3D geological modelling, and it is XField that I will be talking to you about today. So, what is potential fields data? Well, potential fields data is the study of the Earth's gravitational and magnetic fields to assist with geological interpretation. Now, we know that lithologies in the Earth vary in their physical properties, and because of this we can measure it. We can measure the physical property of density, and we're able to use very sensitive equipment to detect these lateral changes in density. Now, this is useful in several geological settings, namely where we have salts and volcanics, or for instance in areas of rifting or faulting. We are also able to measure the physical property of magnetic susceptibility. Now, measuring magnetic susceptibility allows us to detect changes in the magnetic properties of lithologies. So, for example, we know that igneous rocks are more magnetic than sedimentary rocks. And by measuring these different physical properties, we can essentially see what's going on underneath our feet. It's similar to X-rays or CAT scans in the medical profession. We're trying to understand something we can't directly see, and we're trying to do this through the measurements of gravity and magnetics. Now, gravity and magnetic data can be acquired either on land, from the air, or at sea. So, why use potential fields data? Well, it augments seismic investigations, where seismic imaging is challenged. Now, this can be areas of thrusted sections, salts or tectonics. The collection, the acquisition of gravity and magnetic data is often at a low cost compared to other types of surveying data. We can focus more expensive techniques such as seismic data. By mapping the Earth's physical properties, we can often jump-start an exploration process, especially in frontier areas where we really don't have a lot of data yet. Remote and difficult areas can also be surveyed easily using potential fields methods because of the low environmental impact. We can infill 2D seismic data with gravity and magnetic data, especially if your seismic data is sparse. And we can also determine structural and sedimentary complexity by using gravity and magnetic data. So really, we know that using multiple data sets reduces risk, and that's what we're trying to do by introducing magnetic and gravity data into our exploration workflow. So you might be in a situation where you've conducted an airborne radiometry survey, or you have gravity and magnetic data available to you. You also have seismic data, and you've already started interpreting your different seismic horizons. Now, in this case, you could start using XField. We want to integrate all these data sets together into one space, and we do that through OpendTect and XField. So what does XField software do? Well, it's modelling software, and we can use this modelling software to visualize, model and interpret potential field data, so gravity and magnetics, in conjunction with either 2D or 3D seismic data. This allows us to better build constrained geological models, and we can constrain these models by integrating data sets such as seismics, interpretations we already have, and well information. We can use this to help us test seismic interpretations we already have, and from that we can limit the non-unique nature of gravity and magnetic modelling. We can also take this and reduce our interpretation uncertainty. So essentially, XField provides the capability to build gravity and magnetic 2D or 2.5D models on either time or depth sections using either 2D or 3D seismic projects. Now I will move on to our demonstration of XField. So just a bit of background information for you. I'll be using the Penobscot dataset. Now this dataset is provided by OpendTect, and you can download it from the OpendTect website. It's from offshore Nova Scotia, and we have seismic data available to us. We have 2 wells available to us, interpretations we've already done, and there's gravity and gradiometry data. So now if I move into OpendTect, you can see here that by using OpendTect we instantly have a 3D space that we can visualize things in. Within my demonstration project I have a 3D seismic data set. So I'll switch on a couple of inlines that I have selected and a couple of cross lines. If we move down the tree in OpendTect, you can see that I have already interpreted horizons available to me, and I have both gravity data and gradiometry data. Now within OpendTect you can shift this data into different positions so that you can really see how it fits in with your seismic data. I have faults that I've already interpreted, fault stick sets, and we have a couple of wells. So now at this point, when you've collected all your data sets into OpendTect into this 3D workspace, you might want to start modelling. Now you can do this easily by using the XField icon that you'll find in the top of your screen. When you click on this icon, the starting view for XField will open. Now when you want to start modelling, you go to File and New Model. Here you can see that I can either model on 3D seismic data, on 2D seismic data, on an image where you select your image and set the coordinates of the extent, or on no seismic data at all. Now for this example I'm going to be modelling on 3D seismic data, and in OpendTect we just saw that I had inline 1300 switched on, so I'll model on inline 1300. I will select my attribute, and then if I press OK, you'll see that it will populate the XField window. I'm just going to switch off a function that I'll talk about later, but if we look at our profiles first, we can see that at the top we have our gradiometry profile, our center profile is that of gravity, and finally we have a magnetic profile available. Now if I go to File and Open, I want to open my gradiometry data. Now this will open the window you see in front of you, and here I can select my gravity horizon. You should really think of XField as an integrated part with OpendTect. So any horizon that you have already loaded into OpendTect, you'll have available in XField. And further to that, any attribute you have loaded onto that horizon, you'll also have available. So in this case, I want my gravity horizon, but I want my attribute of gradiometry. Now you can see that a blue profile has appeared in our top profile, and this is your observed data, or our observed gradiometry data. I will follow this process and open some gravity data, again selecting my horizon and selecting gravity as my attribute. When I select OK, you'll see that now this blue gravity horizon is available. I don't actually have any magnetic data in this example, so I'm simply going to switch off this profile so that I have more room to work with. By using the keys on your keyboard, you can hold down Control and Shift so I can zoom in to the bottom view. Something to note in XField is that you're actually looking at the real Segway seismic data and not an image. So if you can see here, I can really zoom into the detail you have, and you will have this ability open to you when you're modelling. Now, we did a lot of hard work in OpendTect. I've already interpreted several horizons, and I want to use them to help me model. Now I can do this by going to Seismic and select Horizon. when I do this, as I have the horizons already loaded in OpendTect, they are available to me in XField. I will select a few horizons here so you can see what I'm talking about, and select OK. Now you can see that these horizons are available for you to view in XField. So really, with our gravity and gradiometry profiles loaded, and we have some seismic horizons ready to help us, we could start modelling. You should look at this large black rectangle and see that as your starting body of your model. Now essentially the rules of modelling are to continually split these bodies down until you build up your geological view. You can do this by right mouse clicking in the body you have active, going to bodies and split current body down. By clicking on the end of extent of our body, you'll see that it highlights black, and then I can start splitting this body down. And because I have a seismic horizon to follow, I can actually snap to this horizon, which helps you build models very quickly. When you close this body, the body properties window will automatically open. You can see here that I can either add values manually or I can use the scrolling bar. And in real time you can see that this changes the red profiles, and this is our calculated response. Purely for functionality, I'm just going to assign a colour so I can show you how you would quickly build up a model. So now we have two bodies created in our model, and again if I wanted to split this down, I would right mouse click, go to bodies and split current body. I can choose to follow another seismic horizon in this instance, and when you complete your body, the body properties window will again appear. Now if you don't know all the information, you can use Gardner's equation to help you assign properties to different bodies. So if you know your density, you can use this to set your velocity and vice versa. For magnetic modelling, you can also put in the properties of magnetic susceptibility, as we discussed earlier. So now in our model building process, I have three bodies. Now I could carry on like this, but I'm sure you don't have the time today, so I'll go and open a model that I already have available. You can do this by going to File, Open and Model. The model I want to open is exactly the same seismic line, in line 1300. I'll just discard what I've made already, as it wasn't very accurate, I'm sure you'll agree. So now if you look in the top corner, I'm again looking at a model I've created on seismic line in line 1300. You can see that the correlation between my calculated response, which is our red profile, and our observed data, which is our blue profile, is quite accurate. You can see that I have a more geological model, although it's quite simple. And you can see now, if I right mouse click into a body, I can go to the body properties window, and I've assigned different properties. I can use these scrolling bars to change them if I wanted to create a better fit, if you look in this area, and it's changing our response in real time. What you can also do in your profiles is right mouse click and select Show Current. Now this shows you the effect the current active body you have is having on your calculated response. So for instance, I can see that this green horizon is having a greater effect than a lower horizon. Another profile you can switch on is that of Show the Difference, and this just shows you where you have the biggest discrepancy between your observed data and your calculated response, and it basically tells you where you should work a bit harder. What you can also do is go to Options and switch on the options to filter your observed and your calculated data. When you do this, an icon will become active, and that's your filtering icon. Through this, you can do some basic filtering, low, high and bandpass filtering, and you can choose your taper. You can either use the scrolling bars or you can select the value yourself. And in this way, any geological model that you can create, you can check that it satisfies a variety of wavelengths. Now something I'd like to show you that's available in XField is the option to switch on intersecting models. Now you can see when I did that, these markers have appeared, and if you look in the bottom left hand corner for me, when I hover over the marker, you can see that this is showing us I have an intersection from the model I'm currently in, which is inline 1300, and the model from crossline 1070. you can see if I move over to the second marker on the right that this is an intersection between crossline 1400 and the model I'm currently in. Now what's useful about this is that you can quickly build multiple models in an area, especially where you have intersecting points. What you can also do is jump into another model. So if I hold down the Control key on my keyboard and click within this intersecting model, I discard the changes I've just made now, and it will actually jump me into that model. So if you look in the top hand corner now, you can see that I'm in the model for crossline 1070. But if I hover over my markers, you can see that this model intersects with inline 1300 and inline 1500. Now if we look at this intersection with inline 1300, you can see that I have 1, 2, 3, 4, 5 different bodies in the space where in the model I'm currently in I only have one large green body. So I can use this intersection to help me advance the model I'm now looking at. Again, if I click within the body, go to bodies and split the current body down, I can use the markers, not very well, to help me work across the body I'm in. When you finish the body, again the body properties window will appear. I'm actually going to ignore that for a while and move ahead, even though it's a little bit rough. I want to show you quite a clever little trick that you can do in XField. So all I'm doing is selecting a body and splitting that body down and sort of using those markers, the intersection points, to help me navigate. Oh, not very well. Okay, so now I've completed that body. So what I've done is essentially taken the green large body and split it down into 1, 2, 3, 4 different bodies. And I want to propagate these bodies with the same properties I had when I was in inline 1300. And I can do this by dragging and dropping. And I can do that for each body that I've just created. And now you'll see that in the body properties of this orange body, for example, I have the density set to 2.63 and the velocity is 5209. I can now jump back into the model I was in, and I will use the arrows, the icons on the left hand side, to help me do this now. And you'll see that the properties of the orange bodies match each other. In this way you can quickly build multiple models and drag and drop properties from one to the other, which really helps to build your geological knowledge of an area very quickly. So I'm now happy with the extent I've taken this model to. I believe that the fit between my observed and calculated response is fair enough. I'm happy with it, it's good. So what I want to do is export my model, and I can actually export bodies also. You can export bodies by right mouse clicking in a body and going to export body. But what I'd like to show you is how to export a model. And you can do this by going to File and either export the model as an ASCII. If you select this option, you can choose the horizontal sampling and the vertical sampling and the properties that you'd like to export. Now bear in mind you have to have set these properties beforehand. If I want to export the model as a segY file, I can do this by going to File and Export Properties as a segY. When you do this, you can choose to export your model to match your seismic data, or if I only wanted, say, to export the model within this little section of the seismic data, I can put in the distances for my horizontal sampling and vertical sampling. Again, you would select the property that you want to export. You would type in a file name and choose somewhere to save it. What you have done here is exported a segY model file of the property of density in this instance. Now what's key is you can now import that back into OpendTect. You would do this by going to Survey, Import Seismics and segY. You would select to import a 2D line, and from here you would navigate to where you saved your seismic file. Your segY file. Now I've already loaded these, and you can see that if I switch them on, you're seeing segY files with the property of density on them. And in this way we're using XField with OpendTect to really build a 3D view so you can integrate all your datasets in one space. Now something I should have mentioned before, and it's quite difficult to show on one screen, you actually have link cursors between OpendTect and XField. I don't think I can show you now, but when your cursor is moving on the seismic data in XField, you will see the cursor on your seismic line in OpendTect. Now that concludes my demonstration for now, so if I move back to our PowerPoint, I will just summarise what we've covered today. Potential fields data, gravity and magnetic data, enables explorationists to gain a better geological understanding of an exploration area. By integrating multiple data sets by using OpendTect and XField together, we can decrease exploration uncertainty, increasing confidence, reducing costs and risks. XField, as a plug-in to OpendTect, empowers an explorationist. We're trying to give people the tools so that they can integrate all their data sets together. Thank you very much for listening today. Now, XField is available as a free evaluation for 30 days, and that's available from now. If you'd like to send any requests or questions to me, please do so at software@arcex.com. And I thank you for your time today.
Thank you very much, Anna. I think this was a great presentation. Now it's time for attendee. If you have any question, please raise your hand or type your question, and we have the panelists to answer us. So please feel free to do so. It seems that it was very clear presentation, Anna. We have no questions so far, so everybody understood what you said.
Well, I know. Well, that's amazing. Usually I get quite a few questions. But,
yeah.
If anybody does have any further questions, please just send them to me. That's not a problem.
We have a question coming here. Okay, Camille, you can go ahead and say your question loud.
Yeah. Okay, thank you. My question is, Anna, good morning. Because I entered so late, but your presentation was very interesting. I would like to know if it is possible to moderate some different density bodies. I don't know, like for example, if I can apply this kind of tools to modulate iron bodies in a different positions, because I don't know if it I don't know how do I say about it, but for example, if I have some different structures, you show us some folds now, yeah. But I don't know if I have a body, for example, of iron, an iron body. So.
Yeah, that's a good question. I think I understand what you're getting at. You are completely free to add a body in your modeling space. You don't have to adhere to individual horizons. So if you're a mineral explorationist,
yeah,
the seismic section that Anne-Marie was showing you wouldn't quite apply. You would have an intrusive body within there, and you can add that. In fact, I think Anne-Marie is trying to show that on the screen now, which you can see. So you could add a banded ironstone formation or something to that effect. And add an appropriate density to that. Or
a limited body, yeah. Absolutely. If I have a, yes.
Yeah, so you should see
an infinity, yeah. If you can modulate an infinity body, but when this body has some limits, yeah, you can try to think in a 3D dimension, like in a sphere, for example.
Correct.
Or a cube.
So each body in the model can be assigned its own strike extent in and out of the plane.
Yeah.
So you can constrain, and remember it is a 2.5D model in that sense, and not completely 3D, but you can constrain the strike extent to make a pseudo 3D approximation. So where you have a strike-limited banded ironstone formation, for example, you could build that into your model.
Yeah, understood.
Okay, great.
Thank you.
Hey, thank you.
Very
Thank you.
good.
Thank you. Fantastic. Fantastic. Very nice.
Thank you.
Thank you. Thank you.
Frizo, you had another question?
Yeah, do you hear me?
Yes, we can hear you, and all the attendees are listening as well.
Yeah. Hi, nice presentation. I just had a quick question. I actually might have mentioned it, but I might have missed it. What you released is now with OpendTect 4.6. What are you next term development plans with this plugin?
We're currently built up against OpenTect 4.6, and actually I'm in the process of releasing our next XField, which will be available in the next couple of weeks. And really we're just building on different functionality within XField. So the way that you export bodies is now more streamlined. We have different color palettes that are available. We have the ability to set chronostatic graphic age to different bodies. So we have we actually use XField in-house, so we have a very competent interpretation team that are constantly asking me for new features and new things that they want, and so really all the time we are developing XField and take on board people's suggestions as they're using the software.
Okay, thanks.
Okay.
Thanks, Rizzo, for the question.
Any other questions? We have another question came in. Okay, Camilio again. Okay. Okay, go ahead, Camilio.
Because okay, thank you. My second question is about the data from density. They came from the samples or of the walls, well samples. Yeah, so you take the density data from the well samples. Is that?
Yes. So you would use well information, yes, if you had it available to you to help you assign different properties to different bodies.
Yeah, because you show us a drop and drag the colors, yeah, simulating the different values of density, right? So if you
The colors
that colors represents the different values of gravity, of density, yeah, right. When you drop and drag the colors to the seismic, yeah? Is correct?
Yes, that's correct.
So, yeah, also, so sorry.
Okay, good.
Yeah,
okay,
no,
good.
that's fine. So you can choose to color, I'll just finish. If you can choose to color the bodies in your model, either using a color palette, which in the new version actually auto-corrects itself depending on the densities that you assign, but also you can set whichever color you want. So you have full control really of how you want to color your models. Thank you. Thanks for the question. I hope that answers it for you.
Okay, David Conley have a question here. He's saying, can you have a depth varying density? So anybody from the anyone from the panelists can answer that. Can you have a depth?
Yeah, we don't have a function assigned to a body. So the only way you would do that is split your individual bodies into a number of sub-bodies. Think about horizontal layers, add more layers to it, and then incrementally increase the density. So you are doing this in a slightly roundabout way. It is doable, but there is no, I guess you're referring to sort of P mod K function that we do not have in XField.
Okay, thank you.
Good question. I think it's a good question. I think it's appeared on a few lists of requests in the past.
Thank you.
Okay, thank you, Paul. All right, I think by this question we will end our presentation, and I just want to all attendees to know that we have a recording for this webinar, and it will be loaded in our Facebook and the LinkedIn page, and we also will have it available in YouTube video as well. So please feel free to give us, if you have any question, just feel free to send it to us at webinar@dgbes.com. And we have every month a webinar, so we would like to see you again with us next month. Okay, have a good day. Bye now.